Hello and welcome to another video. In this video we're going to be working on count subarrays with score less than k. And in this one you have a score of an array that's defined as the product of the sum and the length. So here, basically for this array, if this is the array, you just do the sum times the length. So given an integer nums and integer k, return the number of non-empty subarrays of nums where the score is strictly less than k. Subarrays contiguous and then 10 to the 5th constraint. So they kind of show you here. So 2, 1, 4, 3, 5, and 2, 1 are. And then in this, every subarray is except for this. Yeah. Okay, so basically how do you do this one? So this one is actually quite simple for a hard, in my opinion. So let's just say we have some numbers and k is 10. So because it's contiguous, right away we're going to be going for like a sliding window, and then you want to figure out, does that work? So if I have a sliding window, is there any like way I can grow and shrink and whatever and get everything? So we can say, okay, let's just imagine our subarray ends at the right side. We can shrink it to see like what's the biggest subarray that can have. So what I mean there is, like, let's say it ends here. So our left is here as well. So what's our like product times length? So this is just 2 times 1. So this is just 2. So in which case this thing is a valid subarray. So we can have like 1 there. And then we'll keep going. So now what's our product times sum? And we can keep track of like a total here. So we have 3, and the length is 2. So the product times, or not the product, the length times sum is 6. And that's fine as well. So if this is fine, then we know anything smaller is fine. So if we have 2 pointers, this is going to show like this is the biggest array you can have that ends here. So anything smaller will work as well. So like this will work and this will work. So the thing we need to add to our result is like how many, like what's this distance, right? And this is just, let's see, right, minus left plus 1, right? This is like how many different arrays we have. Because let's say extreme case, like this was valid, then so would this be, so would this be, so would this be. So, but anything bigger is not. So we add 2 more here, so we get 3. And we keep going. So the total now is 7. And what's this whole thing? This is 7 times 3, 21, so that's too big. So we need to shrink. So now the total is 5. 5 times 2, which is 10, so it's still too big. So then our total is 4, and this is fine. So this is another subarray. Now we go over here. Now this becomes too big. This is 7 times 2, so we have to shrink again. So it's 3. And basically all the rest of these numbers will just be one number. So this gives 1 more array, this gives 1 more array, this gives 1 more, and so on. So we have 8 total, I think. I added extra numbers here because this wasn't the same example. So in this case, with 7 numbers, you would have 8 subarrays, because the only one that can have multiple numbers is this. So that's basically the idea. We just shrink as far as possible, and then we make sure, like, if our number is just strictly bigger, like let's say k is like 10 and our number is like 15, we just won't include that. We'll just completely start over. So we can have that case. I'll just shrink. It'll work out anyway. But essentially that's all we do. We just shrink our subarray to as much as possible, and then as long as we hit this condition, then anything smaller will or we don't shrink as much as possible. We shrink until we hit this condition, and then anything smaller, like any subarray from the left to the right, will be valid. So we'll just add all of those. So pretty simple. So we'll just say like result equals 0, left equals 0, total equals 0. You can do this, I guess, too. And so we're just going to add, and we're going to say while left is less than or equal to right, because we don't want to go like out of bounds or anything. And total times, so the length is right minus left plus 1, is greater than k, or greater than equal, has to be strictly less, then we'll shrink. And now we can just add right minus left plus 1. If we don't include this element, what's going to happen is left will actually be past the right. So if we have an array of like 10, 15 or something, and k is like 2, what's going to happen is the right will be here and the left will actually be here. So right minus left plus 1 will be 0. So that's it. I do think it's quite easy for a hard. I mean, so yeah. Also interesting, yeah. So you can see in this video, yeah, like you can actually see the difficulty, which is kind of nice. And you can do that by have this extension. I think I shared it before. Where is it? This LeetCode difficulty rating, which is kind of nice because it kind of tells you like roughly where this is at. So if this was like 2700 or something, you'd know it would be some insane stuff. Yeah. So and yeah, not much to it. All right, so I'll see you in the next one. Thanks for watching.